In one of the previous episodes, I told you about Venus, about the fact that not so long ago, literally 160 years ago, it suffered a planetary catastrophe. The fact of the collision was recorded by scientists many times in the past, and then confirmed by modern surface scanning. As usual, there are unanswered questions. One of such questions is whether it's possible for a planet to undergo massive bombardment for some 120 years, immediately to dozens, if not more, planetoids almost the size of the Moon in the seemingly peaceful solar system. Definitely not. Or is there? Well, let's try to figure it out. Hello, this is the Epoch of Mistrust channel, and I, its author and host, Mikhail Kalmikov. Well, we continue with you to create the atmosphere of the universal apocalypse. To understand whether such a thing is possible in principle, we need to recall the rules of the movement of planets and bodies in the solar system. Namely, all bodies, including our Earth, move counterclockwise. And the center of rotation will always be the Sun. Even if it's a satellite of Earth, Mars, Jupiter, Saturn, or the smallest meteorite, in the end, they all revolve around the Sun. Some just do it in company. Then another center of rotation appears, for example, the Earth for the Moon or Mars for Phobos, but still, they all revolve around the Sun in one direction together. Objects moving against the general direction are extremely rare, so we won't be dealing with them now. Most orbits are stable and move in a circle, but there are objects that have lost stability for one reason or another. For example, a pebble just caught by the force of solar gravity flying past our solar system. It will fly by at a tremendous speed, passing through the entire system to the Sun, receive a gravitational boost, and fly further into the spaces of the galaxy at an even greater speed. Or two comets colliding with each other in the Kuiper belt or Oort cloud receive an accelerating or braking impulse, and one of them, or maybe both, will leave their orbits and fly along a strongly elongated parabolic trajectory. And again, their route will pass by the Sun. They will pass through the entire solar system to the center of mass of our star, and receiving a gravitational slingshot will head into the void. This is how comets and meteorites form, according to the official explanation. Imagine that somewhere, for example, in the vicinity of Jupiter or even closer, somewhere in the asteroid belt, an entire planet exploded. Then its huge pieces would receive impulses in all directions. And undoubtedly, some part of them will receive a negative impulse, slow down relative to the general speed of movement, and will fly back to the Sun along an elongated orbit. Some of the fragments will fall on the Sun, some after a series of interactions with other planets will take a stable circular orbit, and some will continue to fly along an elongated trajectory around the Sun. Thus, a new short-period asteroid, meteorite, or comet will appear. No matter what event caused the change in speed or direction of the asteroid's movement, such an event is possible. The very existence of comets and meteorites already speaks to this. So let's assume that one of such events has occurred. Well, for instance, the explosion of a planet between Mars and Jupiter as an option. As a result, a huge amount of debris is formed, some of which, as I already mentioned above, slows down and flies straight to the Sun. But the other part of the debris, those that have accelerated, will also fly to the Sun, but by a different, longer path. Thus, the exploding planet, like a fountain, sprinkling everything around with droplets, gives birth to a huge amount of asteroid spray. They will fly in all directions, but at different times. Sooner or later, one way or another, they will all at some stage of their orbit fly past the Sun, next to the Sun. Regardless of the trajectory taken by the newly born asteroid perihelion, its orbits, that is, the point closest to the Sun, will simultaneously be the point at which it reaches maximum speed. Thus, a stream of objects is born, scattered throughout the solar system, but with a certain periodicity, returning to the point of their birth, albeit at different times. And they will all, one way or another, pass close to the Sun. Thus, the further our planet is, the less chance it has of encountering one of these comets. It's safest somewhere on Mars, closer to the Sun. The Earth's chance of encountering a comet increases fourfold or more as it gets hotter. Fortunately, we now have the Moon, and it partially protects us from large objects. Closer to the Sun is Venus, where the chance of encountering a passing asteroid is 4 times higher. But at this stage, the speed that the object has gained by this time saves it. Thanks to it, Venus only needs to fear a direct hit, and while such a chance is significantly higher than on Mars or Earth, it is still quite small. The gravitational pull of Venus simply can't catch a fragment moving at a tremendous speed past it. Moreover, a collision with the planet at such speeds, as was calculated about 80 years ago, would simply tear it apart. In one of the previous films, we paid a lot of attention to this. We even found mentions in history that some civic objects literally rolled across the surface of Venus, and modern scanning of its surface showed the presence of furrows from pole to pole, which apparently these objects left. But this is impossible. For an object to be on such a close trajectory, without crashing into the planet, it must have a very low speed. How? Actually, no way. Unless there was another normal large planet comparable in size to Venus in the place of Mercury. The thing is that Mercury is even closer to the Sun, and it is literally on the trajectory of all asteroids. The chance of encountering a comet is the maximum of all possible, and in any case, whether it's a direct hit or a speed encounter, the maximum is also. At such a short distance from the Sun, even a trailing comet trajectory will be equal in force to a head-on collision. Therefore, if there was ever a normal planet in Mercury's place, it had no chance of survival. This planet was doomed to be bombarded by all the comets and asteroids passing by it. And here's where the most interesting part happens. Direct hits on the surface by massive bodies will inevitably tear the planet apart, leaving only a dense metallic core. However, these fragments will not simply continue to rotate along the previous orbit of this planet. Each fragment will also gain momentum and leave the orbit. In fact, the consequences will be the same as in the case of an explosion on a distant orbit, which we described at the very beginning, but with one difference. And here the matter is precisely in the distance from the Sun. The fragments will not be able to fly far from the previous orbit into space. The proximity of the Sun will not allow it. However, these fragments can quite reach the orbit of Venus. And now their speed and trajectory will be perfectly suitable for a soft capture by Venus. In this case, she will have enough time and opportunities for a slow and imperceptible approach. Perhaps this is exactly how the asteroids of the inner radius appeared, which are located inside the orbits of Mercury, Venus, and Earth, so-called Apollons, and from Proto-Mercury there was only a metallic core left. This is certainly confirmed by astronomers who are inclined to think that Mercury's rock composition contains a lot of metals, which makes it quite dense. But maybe I'm exaggerating too much. Judge for yourselves. A hypothetical explosion of one planet somewhere between Mars and Jupiter would inevitably lead to the destruction of 2 more planets. There are ideas circulating on the internet that such a planet was called Phaeton and perished as a result of an interplanetary war, leaving only an asteroid belt in its wake. But if intelligent life existed on all the planets of the solar system before this, Would anyone have had such a foolish thought to destroy their own planet in order to annihilate the others? No one would benefit from this. Nevertheless, speculating about the reasons is a whole topic for a separate video. And now we are interested in confirming or refuting this hypothesis. We already have some confirmations. This is the observation of Venus's satellites in the 18th, 19th centuries. These are strange poles, streaks on the surface of Venus. In addition, cosmic confirmations are the current state of Venus and Mercury and the presence of asteroids within the radius. There is also a theoretical justification for the mechanism of the destruction of two planets, Mercury and Venus. To confirm this theory, I think we need to find in history a moment when such a comet attack was most intense, if, of course, there was such a thing. The classification of space objects with the subsequent selection, according to a given characteristic or a series of characteristics, is a very laborious, long, and thankless task. Of course, there are now databases of the same National Aeronautics and Space Administration which have all the necessary data, and this, of course, greatly facilitates the work. But the data that interests us does not lie on the surface and does not belong to the category of standard parameters of the object, such as its speed, density, or weight. We are interested in more specific information, for example, when and where this object crossed, for example, the orbit of Earth, Mars, or Venus. Almost everything has to be checked manually. How to deal with the huge pile of space junk? After all, if a collision occurred in the distant past, then the object no longer exists. Physically, it's not there. And those that have survived have a slightly different orbit, close to the planet's orbit, but still not intersecting with it. However, the first probe, Para, has already yielded its fruits. The comet with the longest known orbit period, known at this time, is 153 R, and Kaijana, making one rotation in more than 366 years, immediately fell into the list of suspects. Because her previous flight was on September 6, 1636, and on that day her orbit passed suspiciously close to Mercury. In fact, if her perihelion was 12 million kilometers closer to the Sun, she would not just be in Mercury's orbit that day, but in Mercury itself. Do such coincidences happen? And a deviation of 12 million kilometers can be explained, for example, by the fact that at the farthest part of its orbit, deep beyond the Kuiper belt, its speed drops almost to zero, and any slightest interaction can affect its distance at the next pass. That's why I decided to kill two birds with one stone. Firstly, to find the date or dates when comets massively passed through one part of space, and secondly, to find this date not for Mercury but for Earth. In the end, what difference does it make which planet we are looking for? The important thing is the fact itself, the possibility of a massive comet flyby, right? And if we prove such a probability for Earth, then for Mercury it will be proven automatically. Yes, and it will be 10 times higher at that. In this regard, the law of inverse squares fits well here. So I took 18 comets, whose perihelions are at a distance of 1 astronomical unit plus or minus. This means that all these comets either have a chance to collide with Earth or were formed in the course of a collision on Earth's orbit. For each comet, we will indicate its cycle and the date of the last perihelion passage. After that, we calculate the dates of the perigees back in time and see if there were years when they were all at the same distance from the Sun. Taking into account that with each passage the comet's size decreases, we will give preference to the oldest dates when the comets were much more massive. By the way, this list immediately included the favorite comet of some, the third Biela, as well as the eighth comet, R Tutlia 41st R Tutlia Jacobini 55th R. Temple Tutlia and 109th R, Swift Tutlia. What a brave guy this Tutlia is after all. So, 18 comets were selected, and 3 of them passed in 2017, 1 in 2016, and 3 more in 2018. Maybe this is what caused the unhealthy noise and fuss among the authorities. Well, okay, they are small now, let's see what was before. We won't go too deep, let's start with the 16th century. And here we have the first interesting date right away, the year 1524. Immediately, 6 out of 18 short-period comets passed their perigee on Earth's orbit, and 2 of them are Biela's comet and the 8th R comet. It happened almost simultaneously. Unfortunately, neither the simulator nor the official National Aeronautics and Space Administration website consider orbits so far back in time, so we can only guess where exactly their route passed. The next mass passage of comets was already in the 17th century from 1680 to 1690 years. 7 out of 18 comets have simultaneously visited near Earth's orbit. Moreover, 3 of them are the same as 100 years earlier. This period coincides with the troubled times in Russia under the rule of false Dmitri. Whether these 2 events, astronomical and political, are connected, it's hard to say without clear evidence. However, the next parade of comets may strongly shake the positions of skeptics. This is the year 1724. Already 8 out of 18 possible comets passed through Earth's orbit in 2 years. And these years were difficult for Russia. The mysterious death of Peter, and 10 years later the unsuccessful campaign to Turkey, when the Russian army suddenly became very small and could not even move through its own territory due to lack of food and water. Where have all the villages, cities, people gone? Everything is buried in sand and clay. There's a rumor going around in Russia and Europe, but the cherry on the cake is yet to come. The 14th century period from 1816 to 1818. 12 out of 18 possible comets passed by Earth, and 2 more are expected next year. And these years were remembered in history as the years without summer. This fact makes us seriously reconsider the trajectories of comets, which we will do. For this, we will use not our favorite simulator, but the official National Aeronautics and Space Administration tool. The link is in the description. So, the first comet we're going to look at is the famous 3D Biela, and National Aeronautics and Space Administration's database shows a slightly different but also very interesting date, November 21st, 1800. On that day, Biela's comet passed just 12 million kilometers under the Earth. It seems far, but it was not just a pass. It was a pass right through the Earth's trajectory. And just 9 days later, the Earth passed exactly through this place. Only 9 days separated us from the disaster. That is, if it had passed just 9 days later, the comet or its fragments would have collided with the Earth with 100% probability. That day we somehow miraculously avoided the disaster, or did we not avoid it? In history, there are many mentions of the Napoleonic Wars, the typhus epidemic, the fire in Moscow, the Civil War in America, whatever you like, but not a single mention of the comet. National Aeronautics and Space Administration claims it happened, but history doesn't support it. Here's how to calculate it correctly. Could this episode have been cut out of history? The case with the anti-terrestrial mechanism shows yes, only by some chance his description remained with Lomonosov. But then the fire in Moscow could have been not in September, but later, in November. We will discuss this separately. And at the same time, the Napoleonic Wars are going on. Before this, Moscow was seized by a strange fire. They blame anyone for the arson, Napoleon, Kutuzov, or even an alien. However, maybe it's simpler. Could the Earth have just crossed paths with the tail of comets escorting this comet? Yes, simply. Possibly that's what happened, since the comet itself was in the stage of disintegration at that time and officially disintegrated 36 years later, leaving a meteor shower behind, which in turn confirms that it was not exactly a comet, but rather an asteroid, the composition of which, among other things, included various light gases. Astronomers believe that another comet, Biela's comet, was once part of this comet, based on the fact that their orbits are very similar. However, despite the similarity of the orbits, they do not coincide at one point. But what's most curious is that such a close approach of the comet to Earth would surely have been noted and described in literature, yet there is no mention of its visit in November 1812 anywhere. Perhaps that's why researchers don't pay attention to this fact. And I wouldn't have noticed either if I hadn't started checking. The data about it in Wikipedia gives completely incorrect dates. So we've made a very important discovery. In November of 1812, the Biela's comet passed directly through Earth's orbit just 9 days before it. At that moment, it was in the stage of disintegration, and we were just narrowly supposed to collide with the debris of Oskolkov. Here happens a mysterious fire in Moscow. Napoleon's troops are retreating, and a cold descends on the planet that will freeze the northern hemisphere of the Earth for several years in 4 years. There is much more interesting to say about this comet. If you want a separate video about it, hit like. If not, I'll make it anyway, but later. And we've only looked at one comet out of 14. Let's move on. The next comet on our list is the 8th Russian Tutli. It gives us the date of May 24th, 1780. On this day, the comet passed the point of maximum approach to Earth's orbit. This time Earth was quite far away. However, two facts lead to reflection. First, the perihelion point of this comet is very close to Earth's orbit, almost on it. And second, the orbit of this comet is polar. That is, the comet itself most likely originated as a result of a collision or other impact event. On the other hand, there are no other planets besides Earth in the path of its movement, simply none. That is, whatever event gave birth to this comet, it is in any case connected with the Earth. The next comet is Olbers. Checking its orbit with the National Aeronautics and Space Administration tool, we find that it has no relation to Earth. However, on March 25th, 1787, it definitely passed through Mars's orbit, and it has almost a polar orbit. That is, this comet, like the previous one, appeared as a result of a collision with Mars. Another comet, 26R Grigg-Skelly-Rupa, on March 2, 1787, also passed dangerously close to Earth's orbit and apparently was formed as a result of a collision. But there are nuances here. The thing is, over the past 20 years, it has also passed Jupiter 4 times at close range, which has significantly affected its orbit, either slowing it down or speeding it up. So it's quite possible that in the year 1870 it was much closer to Earth than we think. The next comet, 34 Hale, will be at its closest approach to Earth on May 30th, 1870. And again, as in previous cases, Earth is the only planet whose trajectory this comet intersects. And again, this tells us that it possibly was literally born on that day. For example, having been orbiting Earth for some time and then receiving a gravitational kick from the Moon, it was thrown out as far as the force was enough, and the force was enough for about 20 million kilometers. Since then, it has been revolving around the same orbit once every 11 years, returning to the point of its birth. It no longer crosses the trajectory of any planet. And yes, in the year 1938, this comet was lost, most likely also disintegrated into parts of the comet. 41st R. Tutler-Jacobini-Krisak crossed the Earth's orbit on the 20th of September, 1787. I don't want to repeat myself, it's all the same. Earth is the only object whose trajectory the comet crosses at a maximum close distance of about 8 to 9 million kilometers. On the other end of its orbit is Jupiter, and possibly it somehow affects it, but even at the maximum approach to it between the comet and Jupiter, the distance is approximately 10 times greater. Comet 46R, Vertanina went even closer on the 25th of September 1817, literally 5 days after the previous one. The remaining characteristics are similar. Comet 103R. Hartley crossed Earth's trajectory on the 26th of November 1816, so close that it also suggests its birth in Earth's orbit. And again, as in previous cases, Earth is the only planet whose trajectory this comet crosses. Yes, Jupiter awaits it at the other end, but approximately at the same distance as Venus from Earth, or even further. The Comet 104, Koval crossed the closest point to Earth on September 30th, 1850. I draw attention to the fact that this point of its orbit is simultaneously the closest to Earth, and also simultaneously the perigee of its orbit, and simultaneously the point of transition from one hemisphere of the ecliptic to the other. That is, this is the key point of the comet's orbit. It is from here that she began her life. Well, and the last comet, 4015 Wilson-Harrington, crossed the Earth's trajectory on May 19, 1888. Moreover, she stayed here for a month and a half until June 26, 1888. We've only looked at a few comet orbits out of thousands, only those whose perigees are close to the Earth's trajectory. And even in such a scenario, we achieved almost 100% hit rate. 14 out of 18 comets were literally born in Earth's orbit. This birth mechanism, when the Moon throws out unnecessary pieces beyond the Earth's limits, we have considered in other series. Literally, the Earth actively got rid of unnecessary splinters during its movement, scattering them into space all along its path. At the same time, we received more than a mysterious passage of Biela's comet practically close to the Earth on November 17, 1812. What can explain the mysterious fire in Moscow, the strange winter, and the death of Siberian cities? We observed the meeting point of almost all comets on Earth's path during the 18th, 16th, 17th, 18th centuries, which also coincides with no less mysterious years without summer. We also received confirmation that mass crossings of the planet's orbit by large cosmic bodies over a very short period of time are not just possible. They definitely were and are. And such events can trigger a chain reaction in the system, destroying one planet with a high probability that others will be destroyed in the chain. Possibly in 1812 and then in 1816, 17 and 18, our planet miraculously escaped total destruction, most likely thanks to the Moon. Now let's take the last but very logical step in this video. Why not align the orbits of all these comets to one specific date? Well, to look at the picture as a whole, so to speak. Well, here's for the 17th of July, 2021. Agreed. Let's begin. Comet Biela 8, Tuttle 15, Finley 46, Vertanina 55 now, Tuttle 75, Botina 15 Finley 46 Vertanina 55 Temper Tuttle, 75 Botina Wilson Harrington 103 Hartley 21 Jacobini Zinner and 73 Schwartzman Wachmann. Now let's recall the simulation of the explosion in orbit, which was at the very beginning of the video. As they say, find 10 differences. The orbits of all these comets with a certain periodicity return to one and the same point in space not far from Earth. This is direct evidence that all these comets are remnants of catastrophic collisions that occurred right under our noses. And the speed of disappearance, the fading of these comets, shows that this happened quite recently. One thing can be said for sure now. Judging by the location of these comets, the catastrophe occurred from October to February, approximately. But you ask me a question. So, did the exploding planet Phaeton really exist? Possibly, more than likely. But do I believe that this apocalypse was caused by some war on that planet? No. Firstly, because I don't believe that intelligent beings can be so irrational, well, and secondly, because I have a much more suitable hypothesis. But about this, as usual, in one of the following episodes. Friends, none of us are afraid of mistakes. And if you see a flaw in my logic, then, without hesitation, clearly, literally, and without typos, leave your angry comment under the video. Created the subtitles.